There are two fundamental results concerning the universal set and the empty set. Because the universal set contains all elements under consideration, the complement of the universal set is the empty set. So the opposite of everything is nothing. It says conversely, the complement of the empty set is the universal set, because the empty set has no elements and the universal set contains all of the elements under consideration. Using mathematical notation, we state these fundamental results. So all they're saying here is the complement of everything is nothing, and the complement of nothing is everything. Again, you do not need to use that null notation. You could have just written braces with a nothing in between them if you didn't want to use the circle with the slash through it. Either one of those would have been perfectly fine. All right, so let's get this next part. This next definition is really important for us. It says A is a subset of B, and here's how we write it. It's like a sideways U with a line underneath it. So that's read as subset. A is a subset of B if and only if everything in A is in B. So what you need to do to state something as a set is you need to say everything in A is in B. So if everything in A is in B, that is a subset. So just to give you an example, we saw this earlier. If you remember, we started off with the natural numbers. The natural numbers were the numbers 1, 2, 3 on up, right? And then we went on and we found the whole numbers. And if you remember, the whole numbers had the number 0 included, right? And the natural numbers are 1, 2, 3 on up. So here we could say every natural number is a whole number. So we could say that the natural numbers is a subset of the whole numbers because every natural number is a whole number. But we could not say the whole numbers are a subset of the natural numbers. Why could we say the whole numbers are not a subset of the natural numbers? Anytime there is something in the first set, if there's a whole number that is not a natural number, then they are not subsets. So to show that they are subsets, you have to say every whole number is a natural number. To show they aren't subsets, you just have to find one thing that's not in the set. For instance, the whole numbers contain the number 0. And because 0 is a whole number and it's not a natural number, they are not subsets. Just like with not an element, the way that you say it's not a subset is you just put a slash through the subset symbol. Okay, so here it says, here's some relationships. Now this is going to seem really weird, and we'll get back to this in just a minute. A is a subset of A for any set A. Well, that's trivial. Why? Because A, everything in A is in A. So trivially, it is a subset. Notice if you see that little equal sign under there, if you think about like less than or equal to, that's what you're dealing with here. You're essentially saying A is less than or equal to A. Everything in A is in A. They are equal, so they are subsets. Now, here's the one that'll really mess with your brain. This one says the empty set is a subset of A for any set A. Well, how do you show that? Well, to show the first set is a subset, so the empty set is a subset of A, you would have to say everything in the empty set is in A. But the problem is there's nothing in the empty set. So rather than trying to prove that it is a subset, it's actually easier to prove that it's not a subset. Remember, to say that it's not a subset, we said the whole numbers is not a subset of the natural numbers. We had to find an element in the whole numbers that was not an element of the natural numbers. And we were able to do that. We were able to find the number 0, right? 0 is a whole number, but it's not a natural number. But we had to be able to find something in the first set that's not in the second set. So if you want to tell me that the empty set is not a subset of A, you have to be able to find something in the empty set that's not in A. But that's impossible because there is nothing in the empty set. So if there's nothing in the empty set, you cannot show me that it's not a subset, meaning it's impossible to prove that it's not a subset. And because it's impossible to prove that it's not a subset, that means that it is a subset. Okay, so it's kind of it's called a converse, is the type of proof that you just did there. Really cool, but the empty subset is a subset for every set, so that's something to work with there. And then again, they say here the notation A is not a subset of B. You just put the slash through it. That means it's not a subset. Here's the part that I really need you to concentrate on here. So let me highlight this for you. Showing a subset or not a subset. So if you want to show that A is a subset of B, then you just state that everything in A is in B. And if you want to show that A is not a subset of B, you have to find at least one thing in A that is not in B. Okay. So, example 3 here says apply the definition of a subset. Determine whether each statement is true or false. The set 5, 10, 15, 20 is a subset of the set 0, 5, 10, 15, 20, 25, 30. So again, subset, what does that mean? That means everything on the left is in the right. Is that a true statement? And the answer is yes, everything in the left is in the right, so that's true. So here's what I'm going to write. I'm going to call this A and I'm going to call this B, and I'm just going to write simply everything in A is in B. All right? So that's a true statement. Let's look at part B here. Part B says the whole numbers, W, the whole numbers, remember that's 0 on up, is a subset of the natural numbers. Remember the natural numbers is 1 on up. So are the whole numbers a subset of the natural numbers, which is equivalent to saying, is every whole number a natural number? And the answer is no, that is a false statement. Why is that a false statement? Because not every whole number is a natural number. But what do we need to do? We need to find a whole number. So 0 is a whole number, but it's not a natural number. 0 is not a natural number. So how did we show that this was false? We found, or not a subset, we found something in the first set, 0 is a whole number, that's not in the second set. 0 is not a natural number. How about the next one? 2, 4, 6 is a subset of the set 2, 4, 6. Is that a true or false statement? That is a true statement. Why is that a true statement? Every set that is equal is a subset of itself. So this goes up to above where we said A is a subset of A for all A. Every set is a subset of itself. How about B? Says the empty set is a subset of 1, 2, 3. The empty set is a subset of 1, 2, 3. Why? This is true because the empty set is a subset of every set. Again, I'm not trying to get into the proof of it too much. We did a proof of the converse above to show why it has to be true. But the idea is we can't prove that it's false, so it has to be true. If it's impossible to prove false, it has to be true. So my answers are true, false, true, true.